That's how we can save 1 million trees and 4 million tons actually of CO2 emissions. So that's an environmental impact. Socially, we said about reconstruction, we can rebuild community faster. We can enable less skilled workers to frame and to build our homes, which is young people wants to go in framing, or immigrants, they want to go in framing, and have these barriers we solve for them.
Today I chatted with Mauro Sica, co-founder and CEO of a company called Envision. Envision integrates AI into the construction prefabrication process and involves custom printed tapes for more efficient on-site manufacturing thanks to blueprint automation. Today we chat about this unique construction industry innovation, touching on topics like worker skill shortages, cost reduction benefits, and environmental impact. This is Earth ABC featuring Mauro Sica. Well, Mauro, I'm super excited to talk about AI-driven software in the construction industry with you, and how you at Envision not only help reduce CO2 emissions, but also save construction materials. And then you also have your sights on impacting 1.3 million homes in North America. So again, just super excited to talk with you here today.
Thank you so much for having me. I really appreciate the opportunity to speak about it.
Mm-hmm. And let's say we're meeting for the first time, we're in an elevator, you got 20, 30 seconds to share with me what exactly you guys do at Envision. What would you say to me in this little short elevator ride?
So I would say that we created an AI system to empower the builders to prefabricate on site. So in short, what this means is that we take the construction drawings, we extract information from the blueprints, and then we send this data to a tablet that the builder can use on site, where all the information is perfectly organized. And after that, we actually print out physical tapes. Think of tape measures, but with no numbers, and automatically fabricated for custom tasks. So instead of for the builder to measure and mark everything, you just need to stretch this tape on the material, tape roll like this, stretch it and staple it, and have the layout of every component for the construction. So this is, in essence, AI-driven software plus these tapes. They really enable this on-site prefabrication, which is the most cost-effective system ever created for construction.
Mm. You mentioned prefabrication like on site a couple of times. What exactly does that mean in this context?
So usually prefabrication is done in a factory. And this can be very efficient inside the factory, but you have other costs, and they're impossible to really reduce. So first of all, you have this cost of the huge facility. I visited some of those, and you need to have a golf cart to go around it. It's huge. Plus, you have the transportation of the material. So think about it. If you're in a factory, you need to buy the material, the lumber from a local lumberyard, and then ship it to your facility. At this point, you process the material, you prefabricate the walls, and you need to, these walls, they take much more space than the raw lumber, obviously. They need to be stored somewhere in the yard, maybe outside, moved with a forklift. And then when the construction site is ready, and usually it's never ready when you need to, you need to move those walls on site with the several trucks, not just the one truck that you use for the lumber. So you need to do maybe 6 times more trips, and often very far, because the facility needs to operate in quite a large radius. So you need to ship material and emit CO2 for all those trips to dock on the construction site. So in short, just the transportation, the logistic and the transportation is 10 times more expensive than if you are just shipping the material on site and prefabricate on site. Mm-hmm. Plus, of course, if you have a crisis for a housing, this is a massive overhead cost of the facility, usually force these companies to shut down. This is not something I say, it's something that historically happened in the last 30, 40 years in the United States.
Right. So a lot of the software solves like logistical problems in terms of shortening the time for getting the materials like onto the site, and then also for the deliveries to happen, it's got to go back and forth between the facility and the site. So there's also the CO2 emissions like with the delivery trucks. So there's that impact. But in terms of the problem that you guys are solving, what does that look like, and who is experiencing said problem?
Sure. Okay, let me maybe share my screen so I can show you some images and slides and videos. So the problem we are solving, I mean, probably you need 100 slides for all the problems in construction, but let's say that in short, so first of all, you have a shortage of workers, of skilled workers in the industry. The second big problem is the complexity of the blueprints. This is a huge barrier for people that wants to maybe become a framer, but they don't know how to read the blueprints. And the third problem is that there are so much measuring and marking that inevitably this leads to mistakes. So to give you the idea of the problem that for the blueprints, the complexity of the blueprints, let's say that you want to become a framer. You're obviously English speaker, you're not coming from Mexico, but I don't think you can read some of those notes because they are really full of abbreviations and terms that it's almost impossible for a normal person to understand what they mean. So this is a big barrier, and we solve this problem because we use AI to interpret those notes, extract information, and then we create these digital blueprints. So in essence, then we go to the solution. So the problem is also a lot of inefficiencies in the industry. Then we'll discuss about the solution later, but hope this is kind of an overview of what the problem really is.
Mm-hmm. And so who would be paying for the software then?
So our target customers are framing contractors and general contractors in these three verticals of multifamily, so condominium with apartments, tract homes, meaning cookie cutters homes, like the spec homes that are built by developers, home builders usually, and then the custom homes. So the homes that are built specifically for a client that wants a home in a piece of land. So the general and framing contractors are the one to pay us for this service.
Mm-hmm. And help me better understand how this tape that you guys have fits into the software that you guys also have.
Okay, so what we do in essence is automate the blueprint reading using AI, and then also automate this measuring and marking system using these tapes. So let me show you a video real quick so it's going to be easier to understand. So first of all, about the extraction of the data, we use a combination of AI plus a plugin that we give to the architects to extract all the architectural data. So where the walls are, where the windows are, very precisely. So what we do is take the blueprint and generate this model, the framing, using our software. So the builder at this point, instead of reading these complex blueprints, can have all the information available on the tablet, including a 3D model and a complete sequence of construction. They also need to be built on the floor area, so they need to be built in stages. And the computer shows exactly where to build the walls and what to build. But of course, the software alone cannot really replace this action of measuring and marking. Therefore, we created those tapes that are automatically fabricated for specific tasks of the construction. So for example, for the foundation, so the anchor bolts and the drain pipes, they need to be precisely located before putting the concrete in the form. So this tape, the foundation tape is stapled to the form, and shows the location of everything the builder needs. So drain pipes, they can drive one nail here and one nail here and run a string around it. They have a set of 4 marks for all the drain pipes that go in the middle of the foundation. And all the bolts that they anchor the foundation, they are very precisely located with these marks. So they put these plastic holders in that's it. So for the framing itself, what the builder needs to do normally manually is to figure out from the drawings where to all these vertical components they go. So they need to mark plates and headers. So in essence, the horizontal members of the wall that you see here. So starting from the headers, what the builder needs to do at this point with the tape is to staple the tape onto the beams, then cut the beams to length, and all the information for the components is there. And for the plates of the walls, it's the same. They can start from 20-foot long material and then cut this material to length. So here you see the stapling of the material on the plates, and then the information is displayed here. You can see the precise quantity for each wall. They have these cut marks to cut to length the plate. And let's just say that the time that takes for the builder to staple this tape is more or less what it would take to measure and cut to length. But then they have all this other information already done, which takes much, much longer, of course. So on top of that, we save 5% of the material. And because the computer can optimize the usage of the material, you can see the scrap in yellow. And once everything is cut, it's much, much more efficient. There is less scrap on site. And everything can be put together finally on site. So this is pretty much an overview of what the solution is. I can also maybe play in the background of this video. This shows a little bit more in detail the process where we're talking.
So is there like a intake process where you get like the blueprints, whether it's generated or they're already existing, and then you then generate this tape, and so each of the tapes that you produce are unique to that particular project?
That is correct. Yes, so the tape is customized for the specific project, and each tape is different in essence. So, and they go on every component of the house.
Gotcha. I can definitely see this like one ensuring very high quality and consistent like work across like all of the components in a construction project, but also at the same time enabling less skilled workers to perform tasks accurately. And by default, like you would kind of promote a more inclusive and efficient process in the world of construction.
That is exactly correct, because a lot of workers, they can assemble a wall. They can use a nail gun. They can shoot the nails and assemble everything together. But it's a very different story to start from scratch, reading the blueprints and understanding where all the components they go. It's actually quite complex. I want to give you an example of something that a non-skilled worker probably cannot do. So let's take this wall, for example. This is a reinforced wall for earthquakes in California. So remember I showed you this foundation tape, right? So the foundation tape shows the location of all these bolts that you see here. Now the bolts, they cannot go where the studs, these vertical members are, because you cannot place the washer and the nut, obviously. So they need to go in between. Now, not all the walls are the same. This is a particularly complex wall where there are so much anchor bolts specified by the engineers. One is the distance between maximum 12 inches. And you need to add studs, this one, this one, this one, and this one, every time that the plywood that is attached to the exterior side, the interior side in this case, of the wall breaks. So there are building codes that the person that builds this needs to know. They need to know that the plywood cannot be cut less than 24 inches in length. And if the plywood is both sides, they need to be staggered. And then they need to add this specific wide stud for this specific wall. Other information is extracted from the blueprints. Let's just say they need to take a bunch of information, let's say from 10 different sources, building codes, blueprints, notes, tables on the blueprints, and figure out where these bolts are going before even they start this construction. Now, put yourself in the head of a worker that is now on site, maybe building another home. They receive a call from the foundation guy that is ready to lay out these bolts, and they ask somebody to go on site to mark the position of those bolts. So very unlikely. So it's actually impossible, literally impossible. They will precisely locate those bolts. At best, they can guess 2 or 3. And then the rest of them, they need to be cut. Another hole needs to be drilled out. These bolts, particularly some of those, they are 3 feet deep into the concrete, and they are 1 inch wide. So they require 1 hour only to drill a hole minimum. So all this process is the normality in construction, and it brings so many inefficiencies. While if you actually can create this digital model before, anybody can place those bolts in the position where they go, because it's just a matter of positioning a bolt with the foundation tape and place the studs where they're supposed to go in the wall. But this is not for anybody. You need to be quite smart and experienced to do this right. Otherwise, you end up to waste so much time that then after 2 or 3 jobs, you realize that you don't make any money. After you pay your workers, you get paid, and you have delays and everything. And at the end of the day, you don't make any money. So people leave the industry or just simply don't even enter in it because they think it's not possible for them to do it. And hence, we have this housing crisis. And every time there is a disaster, a fire, or a reconstruction is required, it takes forever to do this because there are very few builders in the area that they can do this right. And the other ones, they are not even qualified to do it. So these few builders need to build an enormous amount of homes. And it takes years and years and years to build everything.
So how much time and money does your, I guess, company save these workers for an average build project for a home?
So we can have a nice slide of comparison here. So depends on the type of home. Remember, I told you there are 3 verticals. This system is the most effective in complex custom homes, such as the one in LA that they got burned out. So those homes are all very complicated and expensive. And this system saves 4 times, so it's 4 times faster on site to build. And to the builder, of course, I need to pay our fee. But here you have a breakdown. Let's say that you have a crew that they build every year 6.4 homes. And they traditionally, they have this bottom line at the end of the year. They build 6 homes, they make a certain profit, and they make $100,000 per year, for example. Now, if they use our system, because they can build faster, and they can do they can build more homes and make more profit of which homes they build, because they save labor. They can, even if they pay our fees, they can still more than double their bottom lines. So that's the value proposition to the customers. So why not to use it, right? Because our system is so incredibly cost effective to manufacture, because in essence, it's a tape and software, that we can provide this service very cost effectively to builders.
Right. And I know that some people say like construction is one of those industries that's slow to adopt new tech. What makes you guys at Core Envision something like that's an exception?
That's a very good question, Sean. So why this is the perfect fit for the market? So first of all, because there are no significant changes to the builder process. So the builders, they can build exactly as they were building before, just instead of using a pencil and a speed square and a tape, they use this tape. It's such a minimal change, very comparable to go from a corded, a normal traditional power saw to a cordless power saw. I mean, it's just a minimum change. Yes, you need to swap the battery, change the batteries, but pretty much you're doing the same thing. And also, so it's a perfect fit because if you compare it with other prefabrication, because you don't have the cost of prefabrication and the factory, as discussed earlier, but you have mostly all the benefits. Maybe about 90% of the benefits of prefabrication in terms of speed and savings on site. So this is also the solution that is at the lowest cost. So why is better than, for example, prefabrication? Because the builder wants to also build and take pride in actually building. If walls are prefabricated, they actually need to pay a lot of money for those walls, and they become installers of those walls. And also another big point that you don't even require any training here, because it's so simple that usually when they explain the system, 5 minutes in, they say they get it. I mean, it's so straightforward. They used to staple tapes and then put everything together exactly like they were the traditionally marking. So we can compare, for example, to specific to prefabricated walls, which are those type of panels. Remember I mentioned earlier that they take 6 times more space to be shipped. And you can see why, because obviously there is a lot of empty space between the components. So if we compare our system to this, first of all, as a company that prefabricate, we require 1,000th of the capital. Then 100,000 smaller facilities. Still, we need a little space for this printer and the tape to be shipped, but obviously is insignificant. And you can imagine also the shipping costs. We were talking about the shipping costs for those. You cannot compare shipping a box of tapes with the shipping hundreds of those walls, obviously. There is no crane required for our system. That's another additional cost that I didn't mention earlier. So these walls need to be craned in position because they are too heavy. And in our case, you don't need to do that. And also another advantage that you have a much shorter lead time to the builder. Those walls, because of the logistic problems and the facility limitations, sometimes they need to be planned for the construction of months in advance. While now with our system, printing the tape requires maybe a couple of hours. So it's much faster to do last minute modification. By the way, it always happens that you do last minute modifications and then print the tape and ship it to the site. For example, you can ship the first wall first, the second wall later, at the very last minute, and that's possible with this technology. So that's why it's a perfect fit, because it actually solves the problem of the industry. Unlike prefabricated walls, they actually don't. And that's why they are not used in single-family construction, but they are only exclusively used in multifamily, where the capital of buying the land and developing these bigger condominiums is so high that the developer needs speed and prefer to pay extra for the prefabricated walls to have this speed, so they can rent out the units earlier.
Gotcha. And having that collision between like AI and tech and also construction is like a very niche area. What about your background aligned you closely with this type of problem? And so what I'm trying to ask is like, what inspired you to start Core Envision, and why are you the right person to solve this problem?
Thank you for the question. First of all, my background is in software and architecture. I became an architect after studying software. And then I started to work as a construction manager a lot, because I was always been intrigued by the technical aspect of the construction. Let's say that even if I am an architect, I study architecture, I'm more an engineer than, I'm also kind of close to an engineer in terms of knowledge and passion for the construction. So what inspired me, because I really saw firsthand the pain in construction sites, how hard it is. And also I had friends, they lost their homes during the fires in California. And I saw their pain too. And I thought to myself, not many people have the background that I have in software and in construction. So, and also I have the ability to come out with the solutions and talk to people and to the customers. And sometimes they come out with the brilliant solutions that we adopted. But I think people everybody of us have a particular talent, and we kind of have the responsibility to use it, to give something back to the world. Otherwise, it's a waste. So I felt the responsibility to jump into this difficult industry and find a solution for it, to help both the housing crisis, to help the crews that they want to build homes, and they can actually do it. And so if they build more homes, of course, there is the possibility that the cost of homes for everybody will lower a little bit, because now we cannot cover the demand for new homes. And on top of that, the reconstruction. So if we can go 4 times faster rebuilding an area, that's huge. People can actually start to relieve, go back to normal 4 times faster. So maybe in a couple of years instead of 8, which is crazy, but that's what actually happens. The fire in Santa Rosa, a lot of homes are not rebuilt yet. And who knows how long it will take for Los Angeles to be rebuilt.
Right.
So
you worked on 3 interesting projects so far. Could you share a little bit more about your traction today?
So what we did is to build, so we are a pretty new company, but we managed to build a few homes with the system. This is an example of the last home we built. You can see the tape on the plates here and here. And here the plates are not assembled yet. And this is a guest house of the main house. It's a 4,000 square feet home, custom in Sonoma. And you can see that this IDU, for example, was built in a few hours, the walls at least. This is the main house. You can see the tape everywhere here, and also on the windows here. Then they show the location of the seal and the header. And again, this is a crew that was actually experienced, and they managed to build this home extremely fast. Everybody was impressed, even the lumberyard, because they saw the speed. They were bringing the material one day, the next day, all the walls were up. So it's the walls were actually built in 18 hours, and the entire framing was finished in 2 weeks, which is at least 4 times faster than any estimation of time the homeowner got from other builders, other framers. So everybody was saying 8 to 10 weeks to finish this project, and maybe it was going even longer than that. But this framing in particular went so smoothly that it was finished in 2 weeks. You can see very clearly the tape everywhere. That needs to stay there, by the way. Once the plywood covers it, nobody sees it, and it's fireproof and is approved. So we managed to build 3 homes, and now we are in a stage where we are raising money to grow the company and also hiring people. So if anybody wants to be involved in this as an engineer or in sales for this project, we're looking forward to hire people and to grow the company.
Mm-hmm. Definitely shouting out that aspect. And for the last, I guess, couple of minutes of our time, I'd love to finish off with what type of impact are you hoping to make in the next 5-10 years?
So we hope to save 1 million trees every year. This is the impact resulting from the CO2 emissions that they go into the process of building, for example, custom homes. Let's say if the crew needs to go on site 4 times less than they usually do, And the engineer and the architects, they don't need to go on site to check problems and solve them with their vehicles as well. Of course, you save a lot of CO2 emissions. We save 5% of the. So that's a huge. That's how we can save 1 million trees and 4 million tons actually of CO2 emissions. So that's an environmental impact. Socially, we said about reconstruction. We can rebuild community faster. We can enable less skilled workers to frame and to build our homes, which is young people wants to go in framing or immigrants, they want to go in framing and have these barriers we solve for them. And hopefully the housing crisis, because if more homes are built, there is more inventory in the market, and usually the price goes down when that's the case, because options.
Gotcha. Well, I'm very much rooting for you guys, especially with all the trees that you are saving, the CO2 emissions that you're cutting annually, and just overall, like being able to speed up the time that it takes to rebuild some homes, especially during events like the fires that happen in California and like all throughout the continent. But yeah, appreciate you taking the time, Mauro, to talk about Core Envision with us. Very much rooting for you. Thanks again.
Absolutely. Thank you so much, Sean, for your time and for the interview.
Thanks for tuning in. If you enjoyed this interview, follow along on EarthABC's LinkedIn to stay connected and never miss what's going on in climate tech. If you'd like to reach out or you're interested in coming on as a guest, feel free to connect with me, Sean Pack, on LinkedIn. We're always looking for inspiring ventures and founders in the climate space to feature on the show. Hope you enjoyed. Until next time.